Hi, I'm Michael Noland, Principal Engine Programmer at Epic Games, and I'm here to talk to you a little bit about the Lyra Starter game releasing alongside Unreal Engine 5.0. First, I'm going to talk about our goals, our development ethos, and cover what all's included in Lyra. Then I'm going to dive into a quick tour of doing modular game development using Lyra. After that, I'm going to hand it over to Simon Lombardo, who's going to talk in more detail about level creation, input, weapons, and abilities. The Lyra Starter game is meant to be an excellent starting point for creating new games, showing off how engine features are put to practical use and updated as the engine grows and evolves over time. Lyra is designed to get you playtesting on day one, with good example of overall game flow from the front end into a match and handling the beginning and ending of a match as well. It's easy to extend to different game types. It's got lots of common systems ready to go, so you can just focus on finding the fun. It's set up for cross-platform development with performance scalability on desktop, consoles, and mobile, and it lets you switch between input modes. So you can do mouse and keyboard, controller, or touch, switch back and forth, as a user picks up or puts down a controller. And then it lets you preview those differences directly in the editor as well. It demonstrates what we think of as recommended practices, so it's accessible by default. It comes with a number of development aids like content validation, developer settings, and various kinds of cheats. And it demonstrates hybrid design with systems built out in C++ and then details fleshed out in blueprints. It's entirely possible to make a game in Lyra using only blueprints, but we definitely recommend this kind of hybrid approach if you have that capacity. And it's integrated with Epic Online Services. Let's take a look at some of the experiences that are included with Lyra. Lyra includes a lot of different systems. We're not going to have time to discuss all of these in detail, but we'll eventually have documentation covering them. Some of the highlights we'll discuss include how different elements of modular gameplay tie together to create experiences, how to create a new weapon or ability, our cross-platform UI implementation, that will be discussed in a separate video, the Manny and Quinn characters and animation setup, our level building tools, how we approach scalability, and our online integration. Furthering the goal of being a great way to get started, Lyra handles a lot of the heavy lifting for you. When you look into the source code for Lyra, it might feel a little bit daunting or that there's a lot of code to understand, but you can honestly ignore most of it when getting started. Treat the source code just like engine code and focus on finding the fun in your game. If your game ends up having different needs, it's designed to be easy to modify and you have all the source available. Before we dive into Lyra's recommended approach for modular gameplay, it's worth discussing the problem that we want to avoid, and also a bit of background here is great for understanding how the moving parts fit together. The Unreal Game Framework includes some actors with special roles for multiplayer games, which include the character or pawn, which is your playing piece that you control, the controller, which describes how you control pawns and also serves as a conduit for clients to request things of the server, the player state, which stores information that other players might need to know about you, such as your current score, and then the game state, which stores information about the game as a whole, for example, the current game phase and the time remaining. There's also the game mode, which is traditionally where server-only code to mutate the game state would live, but in a modular approach, we typically recommend doing things you would have done here in a server-only game state component instead, so that the code and data travel together. It's a natural tendency for these classes to develop structural problems and end up tarballing, resulting in tens of thousands of lines in each class, with long iteration times and everything in the game knowing about each other. This also makes the code brittle, as it's hard to disable or modify a feature without unexpected consequences. So our proposed solution here is to compose new gameplay into these actors instead of adding it all in one place all at once. And we'll talk a little bit more about different mechanisms that we have available to make that possible. First up are experiences, which describe a set of gameplay rules in a modular fashion. You can think of these as a data-driven replacement for game modes. Each experience can be radically different to others. You can switch between a third-person shooter, a top-down arena party game, or a side-scrolling platformer, whatever kind of gameplay you'd like to make. Lyra includes a number of examples. Our front-end menu is actually built as an experience, which eliminates a lot of special case logic. Both the elimination and control point modes in the shooter game example are built in this way. And then we also have a much simpler example to show off, sort of a different set of controls, a different camera mode to the shooter game, which is a top-down arena party game where you basically place bombs and it's a battle royale to be the last person standing. Then we also have a default or a fallback mode, which is the experience that's used when nothing else is available, just to make sure that we can always rely on there being an experience present. This is the front-end experience that you'll see when you first launch Lyra as a game. It has all the standard things that you would expect to see in a front end, such as options, where you can adjust video settings, audio settings, your key bindings, and so forth. You can go and play, where you can do quick play, which will attempt to first find an existing session if it can, otherwise it will host one if it can't. You can go start a game, where you can pick any of the different experiences available, or you can browse for other people who are hosting experiences currently. The objective of the elimination experience is to reach a target score faster than the opposing team by eliminating their members. In the control point experience, your goal is to capture the majority of the control points and hold them in order to score points for your team. Explode is a sketch of a very different experience than the third-person shooter that we've seen before. It's not as fully fleshed out as the shooter game, but it demonstrates how to do different camera, different controls, and a different ability setup, along with things like new attributes. And so as I pick these items up, I'm increasing my ability to place bombs and the range that they explode. This is the default overview map that you'll see when you first open the Lyra editor, and it's launched in as the default gameplay experience where you control this metallic chess pawn. So what all goes into creating an experience? First off, there's a list of game feature plugins to activate. There's pawn data, which describes the hero that the player or bots will control. And then there's a list of actions to perform when we load the experience. And we're going to talk about each of these pieces in more detail. Game feature plugins differ from regular plugins because there's game logic that dynamically controls the activation at runtime, instead of being predetermined by the project settings. In our case, this is controlled by the experience. The plugins can also list actions to perform when activated, just like our experiences can. And they can easily extend the asset manager, defining new primary asset types to scan. There's also an element of enforced modularity, where there's additional asset referencing restrictions in place on content inside of a game feature plugin. What this allows us to do is say that a game feature plugin can reference content in the base game, but it can only reference content in other features if it declares an explicit dependency on those features. And this allows games to safely exclude prototype features from releases, because you can just disable one of these plugins, and if nothing depended on it, you know that it's safe to remove from that build. So actions are a key part of how we approach modularity. They can be contained in game features and experiences. They're responsible for preloading necessary assets and running code when activated or deactivated. Some of the most common actions are add abilities, add components, and add widgets, which are all kind of similar approaches to extending the game, just extending different aspects. Where add abilities is adding like new capabilities to a pawn, add components is adding new logic to one of these different actor types, add widgets is adding new user interface to the screen. The pawn data describes what goes into the hero that the player or player bots end up controlling. First off, it describes what do you see. So what kind of player pawn class should we actually spawn into the world, and what's the default camera mode when possessing that pawn. But it also describes what can that pawn do. So that's the initial ability sets to grant, the ability relationship mapping, and the input configuration. The input configuration can also be specified through an action instead of the pawn data. Ability sets are a group of abilities, gameplay effects, and attributes that be granted to or removed from a player all at once. These sets could be large, you could make an entire game in a single set, or very small, granting just the associated abilities for an equipped weapon, for example. Sets can be granted by hero data, by actions inside of experiences or game features, or by equipment, such as by equipping a weapon. Abilities allow a character to perform some new active or passive ability. An active ability is something like jumping or tossing out a grenade, while a passive ability is something that will automatically trigger, such as the respawn after a certain number of seconds after you've been eliminated. Gameplay effects cause changes to attributes whenever they're applied, and attributes are sort of numeric state for an actor that's exposed to the ability system. So things like the current and maximum health, the number of bombs that you can place at once, the number of bombs that you've already placed out are examples. We'll discuss a little bit more on how abilities are used in practice when Simon talks about shooter game. Everything we've discussed so far is responsible for the under-the-hood implementation of experiences. The user-facing experience, which you can think of as a playlist entry, ties an experience together with a level to play it on and display metadata for the front end. This metadata includes the tile description, icon, and flags like whether or not it's considered a default experience or if it should be hidden entirely from the front end. Non-default experiences still show up in the front end but won't ever be picked by the quick play menu option. User-facing experiences are what's called a primary asset, which means that we can use the asset manager to search for them at runtime. That's how the front end discovers all of them. There's an Inside Unreal video on the asset manager if you'd like to learn more. This is an example of a place where we've provided a decent jumping off point, but the requirements for different games vary dramatically. If you were making a single-player linear narrative game, you might not have any user-facing experience selection as part of your game flow. Well, for other games, you might want to beef up the information defined in the user-facing experience asset, or include an even higher level concept on top of this of a true playlist that has many user-facing experiences to play in rotation. Let's take a look at how these different user-facing experiences are surfaced in the front end. So here we can see the different tiles that represent the user-facing experiences that we've saw defined. Which ones are displayed depends on the setting for whether or not they can be exposed in the front end. And then these two here on this side are what we call the default experiences, which are the ones that Quick Play will attempt to use. We can change a setting here, which affects how this will be launched, whether it's launched via the online subsystem or whether it's a local only match. And then we can also change this setting for whether or not bots are enabled or disabled. This is one of the example settings that we show off, but you can actually add additional parameters and send them down to the server as additional URL options if you have other settings that you want to expose to users. Currently, Lyra has support for user login and authentication, hosting a match, browsing for matches, or Quick Play, which combines the two, automatically browsing first and hosting if needed. These all go through an abstraction layer called the Online Subsystem, or OSS for short. A game can use multiple subsystems at once, for example, using Epic Online Services along with the console's platform-specific version. Epic is developing a new, improved version of the abstraction called the Online Services plugin, but it's still experimental for 5.0. Lyra-specific plugins, Common User and Common Session, wrap up that engine-level abstraction and provide a simple API for game code to deal with for user and session management. These plugins target the existing online subsystems by default and will help insulate Lyra game code from the switch to the new Online Services plugins. You should be able to take the updated versions of Common User and Common Session from Lyra in a future engine release and just drop them into your project in order to help with the upgrade. We've also added an engine feature that makes online configuration a little bit easier called Custom Config, which allows you to define an additional INI layer, which is what we use to configure Lyra's Epic Online Services implementation on Windows for testing or packaging to the Epic Games launcher. We've tested crossplay on Lyra-supported platforms using Epic Online Services, and it should be fine to start developing crossplay using 5.0, but it's very early days yet. We'll be looking at integrating the EOS overlay for cross-platform social features in a future release. Lyra includes scalability settings and device profiles for all of our supported platforms. It also includes project settings, which affect the frame pacing mode and what user-facing options are shown in the video settings screen. Frame pacing, there's sort of three different strategies that we can take. On desktop, we expose a user-selected frame rate limit, as well as very fine-grained video settings. And so you can enable and disable things like VSync and the quality level for each individual scalability category. On mobile, we used sensible defaults and optionally allow you to specify a user-selected target frame rate. And if that target frame rate goes above a certain threshold per device, we'll start to do quality trade-offs in order to potentially be able to hit that frame rate that the user wants. And on console, we allow you to specify different device profiles. So you could specify, here is a fast setting versus a pretty setting. And those presets can be added or removed via these performance settings in the device profiles editor. And it's worth noting that while Lumen and Nanite are amazing technology, they aren't supported on all of our platforms. We gracefully fall back to traditional means if we have to, and that'll work fine if your content considers that possibility. But if you've placed a million instances of huge, high polygon meshes, it's not going to run particularly well on these low-end platforms. Lyra includes the new UE5 mannequins named Manny and Quinn, which are built against the metahuman skeleton, along with a rich animation setup. It also includes the UE4 mannequin and a retargeting setup, making it easy to use skeletal meshes targeting any of these skeletons in the gameplay. Lyra's rich animation setup demonstrates how to build characters with advanced locomotion. The linked animation layers allow anim blueprints to be built in a modular fashion for all the same reasons that we do for other gameplay logic, and also has an added bonus of better memory management in a game with dozens of possible different animation layers that might not all be loaded at once. Distant matching and stride warping are used in conjunction to adjust animations to work with varying player movement speeds, while orientation warping adjusts an animation to work with varying movement angles. The turn-in-place system provides more natural-looking animations when a player rotates in place without moving, playing repositioning animations once the orientation is too great to just twist the upper body. The character movement system in Unreal is typically done via a capsule shape that's around the player, with things like stairs done with two kinds of collision: a ramp for the capsule and camera, and individual stairs as complex geometry for things like bullet traces. The foot placement system tries to adjust feet during the contact portion of the animation cycle to rest on the varying surfaces without penetrating into them. Let's take a quick look at how these animation features work in practice. Lyra also includes a basic cosmetics system as well as a team coloring system. The simple cosmetic system allows you to attach arbitrary actors to the invisible animated skeleton. This is how we do character swaps between Manny and Quinn within the game, and it can be used for either these full mesh swaps or for doing individual attachments like hats or backpacks. It also allows you to choose different animations based on gameplay tags from those cosmetics if you have different animation styles to associate with them. The team color system allows you to drive materials or Niagara parameters based on the current team, watch for team changes, as well as edit the team color display assets at runtime so that you can actually have Play and Editor open at the same time as you're tweaking the colors to see the impact. By default in Lyra, cosmetics are chosen via a pick random character component that we've added to each of the experiences. This component chooses a character part to use at the beginning of the match, and it's persisted because it's on the controller, which doesn't respawn as you are eliminated and respawn. And so here we see it's just randomly picking between Manny or Quinn. You could change this so that it picks from a larger list, so that it always uses a specific character, or you could make this read from a user's settings if you want to allow them to choose their preferred character in the front end. So as we can see, we've got Manny and Quinn here. But we also allow you to override these via editor preferences and sheets. So in Lyra Cosmetic Developer Settings, you can add character parts here and choose whether you're replacing them or you're adding them on top of what's already chosen. For example, if you wanted to add a hat. So we're going to go ahead and replace here. And let's say that we want both characters to be Quinn. And so one thing you'll see here is that when we use the cheat to dynamically change it at runtime, the character may end up in A pose. And that's because it hasn't reapplied the weapon layer. So if we pick up another weapon or we switch between weapons, that will fix that. That doesn't happen if you set it at the start of the match. So, going to go ahead and stop Pi. I've gone ahead and imported a metahuman. So if we go in here, we can see that we've got this metahuman. So let's go ahead and change it so that we're using that metahuman instead. So if we go back to editor preferences, now what we'll see is that this character is in A pose, but it's not for the same reason that we saw before. This character doesn't currently have an animation blueprint set up on it. So let's go ahead and do that. So what we want to do here is we want to find this body and then find the skeletal mesh for that body. And then go to Create Animation Blueprint. So that's created a new animation blueprint that's compatible with the skeleton of the metahuman. Now we go back to where the body was and we go ahead and hook that up. So we change this to Animation Blueprint and then select the asset that we just created. So this still doesn't work because right now the animation blueprint is completely empty. So we need to add a retarget pose node, which will map from the driving animation onto this mesh. So here's the animation blueprint that we just created. And we drop a retarget pose from mesh node, and we choose what the retargeter asset is. And so we provide 3 different ones here. This one is basically from UE5 to UE5. This is from the UE4 skeleton to the UE5 skeleton, and this is from the UE5 skeleton back to the UE4 skeleton. And so you should be able to drive or be driven in any direction that you want. So we pick the UE5 one. Now, if we go ahead and play, our character is actually playing all the same animations that Manny or Quinn would have. But right now, because we're using the materials that came directly from the MetaHuman, nothing is team colored. So let me show you how to hook that up. So go back to this blueprint. Let's say that we want to change the hair. So we can see I've selected the hair mesh, and I'm looking at the materials here to see what the name of the parameter is. And so we can see that there's a hair dye parameter here that is what's driving the hair color. Now we have 2 different approaches we could take. We could go into the base material for this and rename the parameter to be something that we're already driving from the team assets, or we can add this parameter to our team assets. And so let's go ahead and do the latter in this case. So we have these team assets, and we can actually edit these while Pi is running. So let's go ahead and open up the blue one and the red one. Go ahead and get started. So now what we can do is we can add an additional color parameter. Name it hair dye. And you can actually see that the blue character's hair has changed color. Now, so let's go ahead and just copy one of these to start. Then we can do the same thing for the red character. And so now you can see that these characters are, there's an indication of the team color. So let's just dig a little bit into how that works. We open up the blueprint that is driving these characters. We'll go ahead and close the team color assets for now. There's this block of logic here. And so this listens for team changes. This is called once at begin play. And it's got this observe team colors node, which will get called every time that the player's team changes in the game, if you can switch teams. But it also gets called whenever those team display assets get edited for that rapid iteration. And so if we go into here, we can see some stuff that's happening. It will use the team display asset, and the team display asset can just automatically apply to any materials attached to the character. And so that's how the material on the hair got that hair dye parameter changed. You can also do queries for it. And so in this case, we're asking for what is the team color in order to pass that along to a system that it can't automatically apply to. In this case, the stencil outline. Lyra uses the engine's enhanced input system, driving input configuration via hero data and actions, allowing experiences to be different. It can even be added during gameplay if you interact with something like a vehicle or turret that requires different controls. The enhanced input system also provides some nice features like actions, which can contain triggers or modifiers. These encapsulate behavior like press versus hold or shorted input on controllers, so that game code doesn't have to deal with it. You can see the enhanced input documentation for more details on the input actions. Users can also edit the key bindings in the options screen as shown on the right here. So this diagram can seem a little bit daunting with how many different concepts there are, but it's not that bad in practice, and it's already set up for you in Shooter Game, making adding new actions fairly painless. The different assets are so that we can support a variety of nice features like different key presets, key rebinding, and groups of keys and settings, which can be added by other modular features. As mentioned earlier, if you had the vehicle that had unique controls. Starting from the bottom right, we have the input actions from the previous slide representing the logical actions that a player can input, such as dashing or firing a weapon. Moving to the left, the input mapping context has the default keybinds for each action. You could have several of these for different controller layouts. One more step to the left, we have the player mappable input configs, which describe how the input mapping context will show up in the options menu. So these have like the user-facing description text, and they're activated via an action, which could be either in an experience or a gameplay feature. The top half of this diagram shows how a specific input action like dash is connected to the rest of the game logic. Starting from the dash input action, it's referenced by an input config asset, which binds an action to an associated input gameplay tag, and that in turn can be linked to an ability set where it triggers the ability. It could be directly pulled by an ability, or it could be listened for as an ability gameplay event. The input config can be bound via actions or hero data. So in practice, to add a new action to your experience, you'd create the input action, give it default keybinds in the input mapping context, and define what tag it will trigger in the input config. From there, you typically associate that tag with an ability in an ability set. Now I'm going to pass it over to Simon, who's going to talk a little bit more about how we created the content and gameplay in the shooter game experiences in Lyra.
Hi, my name is Simon Lombardo. I'm a senior tech artist and gameplay designer for Epic Game. Today, I'm going to follow up on what Michael showed you and go over how the elimination mode was done for Lyra, as well as the input tag. Then we'll create a custom weapon and a custom ability and implement them into the experience.
So the first thing I wanted to take a look at on Lyra is actually how we built this level. To graybox all our level, we basically use Blueprint and more specifically geometry scripting to actually create tools that let us build this level and adapt them as we see fit during the production. We can then bake them to static mesh as well as go back to a live editable version. So let me show you a bit how they work. If you were to open the map expense blockout, you can select any static meshes and right-click on it, go to Script Action, Swap to Generated Mesh. Now, it doesn't seem like anything changed, but actually this is a live editable version of the geometry, and the editor is creating that geometry in real time. So I can move, for example, the opening, or, change the size of the wall, and adjust a bunch of settings that we exposed for you. And all of that is done directly in Blueprint. Once you are happy, you can actually bake that static mesh, and any other mesh in the level that use this static mesh will then change as well. So if I were to bake now, this one gets adapted as well. And then once I'm done, I can right-click and swap back to a static mesh. So all the edit and all the grayboxing of the map were done using these tools. This happens in anything here. For example, you can select the stairs and do the same thing. You will see all these blueprint tools here that you can open and see how they were done. And keep your eyes open as well, as we're going to come with more video and documentation about it. So now that we know about the experience and also about how we built our level, let's make our own and load an experience from Lyra to be able to play against bot really quickly. So the first thing we'd want to do is just create file, new level, and do a basic level. I'll delete that mesh. So to use the geometry scripting tool, I'll go to my folder tool. Then inside bake generated mesh system, we'll want a cold storage. The cold storage will basically keep track of all the static mesh that you bake and the equivalent with the live version of it. Second, I'll start building something. So I'll take, for example, one of the panel and then center it. And you can see that I have already quite a lot of options here to be able to edit it. And all of that is generated in real time. So once I have, let's say, a piece I'm happy with, I'll go down to generation management. And from there, I'll tell him, okay, that's the plugin where I want it, shoot a map. And the path name, I'll say Tecto. Then I'll keep mesh and I create a subfolder for it. I'll also enable nanite. And I do generated new static mesh. So if I go there, you will see that I have basically a static mesh that was created. So I can then swap this one to a static mesh and just start building my map. I'll pause the video here while I build the map, and then we can see how we can easily use our shooter mechanic inside our new map and play against bots. Alright, I have now a really basic map done, but I have some rifle spawner here, I have also some health pack, and if you want to find, we create a bunch of those for you. So if you go to shooter core, blueprint, you will have ability spawner, weapon spawner, launch pad, All of these are pre-built for you to use, and you can adjust them the way you want. And I'll go more into the weapon spawner when I cover how to create your own weapon. Now, the next step, we'll need to define the experience for that specific map. And to do that, we'll go to the default gameplay experience under world setting and choose an experience. Let's pick up the shooter game experience, elimination mode. Now we'll need to tell where our player will spawn. And we create a version for you that will handle both AI as well as normal player. So click on create and write Lyra, and we have a player start. I'll put 4 of those in each corner of the map. Two, and then 2 more in the other corner. And I'll rotate them to be facing the other direction. Now, we define which experience, which is the shooter core elimination, and we define our spawn point. So that's about it. I could press play now and basically be in the match and already test this map in terms of scaling, of where the flow works, all of that. But it would be nice to shoot at somebody. So I'll quit that. We might want some bot actually spawning here. So to make the bot working, we need 2 things. The first thing we need is a nav mesh, so they'll know where to go. So again, click on create and add a nav mesh bound volume. You will want this box to cover your whole map. And if you don't see the green area that is covered, just press P on your keyboard to go it on and off. So I'll cover the whole map here. All right. The second, if you go to Edit, Editor Preference, we have a Lyra menu here. We can add some cosmetic, but we have also things like developer setting that let us override the number of bots we want to spawn. So for example, I'll say, okay, let's spawn 3 more bots. And we can also decide if we want the bots to be able to attack us or just run around. So I would say, okay, you can attack us. And that's about it. If now I press play, I have bots, they're shooting at me, and the whole elimination mode, including the score, the time counter, all of that is working. And you can test directly against bot. You see the score climbing, the health spark is working, and that's all you need to do to basically create a new map for an experience. The bot is really strong. So now let's take a quick overview on how the ability and the input tag works together. So inside the shooter game, our elimination mode, our default hero, the blueprint class, receive an ability set. Inside that ability set, we have basically an ability, for example, GA hero dash, trigger based on an input tag.ability.dash. So when this tag is being called on the hero mannequin within that experience, that ability will trigger and make the hero dash. So that ability is linked within our input config. We have, for example, here, that tag is linked with an input action. An input action are part of the new enhanced system, which is basically a file that tells how to deal with that specific input, what kind of value is being sent, and things like that. So when that input action is being called, it sent a tag to the pawn based on our hero data. That pawn then trigger an ability from its ability set. So now let's take a quick look at how this is set up with a diagram. The Lyra pawn data has an input mapping. And this input mapping is basically an input action, like we saw that file, that is linked to a key. In this case, L shift is linked to input action dash. It also has an input config that config an input action to an input tag. For example, input action dash to input tag ability.dash. And the pawn receive an ability set that then link this input tag to a specific ability. Input tag ability dash to GA hero dash. So that means that when you press left shift, that tag is being called on the pawn. And the pawn then trigger an ability associated with that tag. Now it might look more confusing at first,
But the idea behind it and everything within Lyra is to make it as modular and flexible as possible. Your pawn class doesn't have all this input inside it. You don't have to, if you create a new pawn, to duplicate node or duplicate function or have multiple input in different class. Instead, the pawn receive is input tag, and ability at the experience start, and then knows what to do with it. That means also that if you were to completely change your pawn class later, it doesn't affect anything within your flow. The ability will still be added no matter what's the class of the pawn, and it will still work no matter what's the class of the pawn. The same if you would want to change your input or to allow more input. All of that is being really modular and flexible to be able to pick and choose what you want per experience and make each experience and each game as modular as possible. Lastly, this could also be to add things when after shipping. For example, you want to add a new value to your pawn or a new input. Let's say that in Lyra 5.1, your pawn can jump and fly. We don't need to modify the pawn class. The pawn class will not be touched. What we would do is simply add a new tag with a new ability and then map these two together. So when you press another button, it will trigger something else.
Okay, so now we have an overview of how the experience work and all the inputs and input type work together to trigger ability. So let's take a look at how Lyra deals with item and equipment. And to be more specific, let's take a look at how the pistol works. So the same way that Lyra uses things like modular block for the experience, it does the same with its item system. It's made of multiple parts that can be mix and match. And at first it may be a bit scary to look at it, but it will make a lot of sense when we're going to create our own weapon a bit later. So let's take a look at the pistol. So the first file that interests us is the Lyra inventory item definition. This is basically a file that will tell what happened when you pick up the item. So in this case is ID pistol for item definition pistol. And it defines things like, well, what's the name of the pickup item and what can it do? So this is set up in fragments. And in case of this pistol, you can add a bunch of fragments and you can create your own. But we have an equipable item. This means that, okay, when you pick up this item, you can actually equip it. And this is your equipment definition, which we'll go over after. Then it's set up things like the quick bar icon. What's the icon of the weapon? What's the icon for the ammo? Then default stats. For example, when you pick up the weapon, it's something like the magazine size or the spare ammo that you get from that item. If it will be the case of a medkit, it would be like how much it heals you or how long it will heal you for, this kind of thing. Then there is pickup icon that are specific for the account spawner. And finally, the reticle option that comes with that weapon. So this is when you pick up the item. That item is then added to Lyra inventory system, and we already built the whole Lyra inventory system. It's pre-built for you to use. And this item gets then added to your inventory. So if I were to play now the game, you can see that when we start, we already have the pistol. But if I were to pick up another weapon, like the rifle, then you can see the icon has been added, how many ammo. All of that is decided through the ID. Now, this item can be equipped. So to know what it does when you equip, we'll go to the equipment definition. So Lyra equipment definition. This is what happens when the item is equipped by the player. And not all items have to be equipable. It's up to you. You decide if you want to add the fragment or not. So in this case, what happens when you equip? The first thing, we'll tell him what kind of actual equipment it is. In our case, it's a weapon. And to be even more specific, it's a pistol. Then what ability set we want to grant. And this basically allows us to override an experience ability set based on that item. The ability set in the experience are set up at runtime. That means we can override them at runtime as well. So, for example, in the case of that weapon, the input tag weapon fire, which is the left click on the mouse. Now, when this item is equipped, we'll then run that specific ability. We have overwritten If we were to pick up a shotgun, then it will be a different ability. If we were to pick up a medkit, then it will be a different ability. So once that item is equipped, this tag is associated with a new ability, and as well as the reload, and we get a passive ability, which is an auto reload. Now, we also can decide when it's equipped what actor to spawn. In this case, be pistol, which is basically just a skeletal mesh with the mesh of the weapon, and it's an in blueprint. And finally, how to attach it, which socket, and if we want to have any kind of offset. This means that you could have a completely different pawn in Lyra, still being able to use that pistol. You just would have to change the socket if you don't have the same socket. So now we change the ability. That means that when we fire, we trigger that new ability, which is called Weapon Fire Pistol. So if I open that ability, it's a child class of an ability we already built for you that's called Weapon Fire. If I open that one, this ability basically trigger, first of all, is linked with the Weapon Fire tag, but also trigger things like the line trace and the prediction and the damage done and all of that, and expose a bunch of variables to be able to have a child class that is easy to set up for a new weapon. So if we go back to the pistol version of it, we can see that it does that specific gameplay effect damage. And I'll go over that when we create a weapon. And then which montage to play, and what's the delay in second between each shot, and what's the fire rate, and all this kind of thing that are specific to when you shoot. Not only that, but you will need to calculate the specific damage. And to do that, we'll use the weapon instance information or the item information in case of a medkit, for example. And what this one does, as it's a weapon, it's based on a weapon class, be weapon instant base, and this one deals automatically with things about the line trace and the damage. For example, how many bullets to shoot, how far can it go, what's the sweep radius, what's the distance fall off, all this kind of thing, what animation to trigger when you reload, or when you equip, and your bloom setting. For example, here you can see that the more I shoot, the more the bloom will go, and I have also a modification to say, when you are crouching, the reticle will change and all of that. So if you were to see when I shoot, the bloom goes further, and then if I go to ADS, I zoom back in, and it's really a tight reticle. So all of that is dealt from the ability that then call the weapon instance. And this one decide how that weapon react and how it does its specific damage. And that's this guy working together to be able to create that weapon. And again, the reason we do that the same way as the rest with Lyra is to have building block within a chain that we can change one or the other as the way we want. For example, you could have another item equipable that doesn't override the weapon fire. Instead, it's a jetpack. You override the jump. So when you equip that item and you press jump, you don't do a simple jump anymore, but you can actually fly. Or it's a medkit that does, healing, or any kind of thing you can imagine from an item that can be equipped or not. It could be an instance. Instead of picking it up and being equipped, you basically pick it up and it automatically heals you. All this kind of thing can be decided within the item definition. To go back over one more time, the item definition decide what happened when you pick up the item, and then base if it can be equipped or not. It will go to an item equipment definition, Lyra equipment definition, that will then decide what ability it override and what happened when you actually use it, as well as cosmetic thing. So now let's create our own weapon so we can understand better how all of these files work together. All right, so now we have an overview of how the gameplay experience work within Lyra, as well as how the input tag relates to the input config and the ability, and how the item definition and equipment definition work together to create a weapon system. And I think the best way to learn about weapon is actually to create one. So let's do that. Let's right-click inside the weapon folder and create a new folder. Let's create an SMG. We'll use the pistol as a model, and then have it spread much larger with a bigger magazine and a faster rate, as well as being automatic. So in that folder, the first thing we're gonna need is an item definition. So we can actually pick up the item and it can be added to the inventory. So let's create this one. Right click, blueprint class. And here, look for item definition. Select. Let's call it ID SMG. And let's open it up. All right. So first of all, let's give it a name, SMG. And let's start adding fragment. The first fragment we want to add is obviously to be able to equip the item. We don't have yet an equipment definition, but we'll create one in an instant. Second, we'll want to add some quick bar icon. So when we pick up this item, the quick bar will populate with icons. Right, so I'll open this. For the weapon, let's take the pistol. And for the ammo, maybe we'll take the shotgun. So this way we'll see a difference between the normal pistol, as well as the display name. It's not necessary here because that quick bar doesn't have it, but in case you want to use one with text, you can read from that data. Next, let's add some default stats. All right, so the first one we want to add is our magazine size. And let's do a magazine size of 32. Then let's add our magazine ammo. So 32 as well. What that means is that the magazine size of 32 will be filled with 32 bullets. And finally, let's give our players some spare ammo. Make this one 64. Next, we'll want to add our reticle. So let's add another fragment. And let's choose reticle config. Close this one so we see a bit better. And inside the reticle, we'll use the same as the pistol, so we don't have to recreate the widget. So reticle pistol, add another one, and ammo counter pistol. And we are set for this. The next step we'll need is our equipment definition. So let's create this one. Right click, blueprint class, equipment, and Lyra equipment definition. We know it's a weapon, so we'll start it by W. And let's open this one up. All right, in here we're gonna need a few assets. We're gonna need the weapon, the item instance, that will decide what kind of item it is and what does it do when it's equipped, as well as our ability set that we're gonna grant the player when he equips this item, and finally the actor to spawn. So in here, let's use the pistol for this one, and let's attach it to the weapon R socket with a transform of -90. That is why I was saying that most likely when you're gonna do that, you would be able to copy paste multiple assets and just change a few values. But I find it interesting to create the asset by yourself so you learn more how they relate with each other. All right, next is our ability set. This is a data asset. So let's create it. Right click, miscellaneous, data asset. In here, let's look for Lyra ability set. All right, ability set, SMG. Let's open it up. And we know we'll want to overwrite two ability, which is the weapon fire and the reload. And we'll want to grant a passive ability as well. So we don't yet have the ability, but we know already the tag we'll want to change. So one is the weapon fire auto. The difference between the fire and the fire auto is the fire is only when you click, it does it once, and fire auto is when you click and hold, you keep doing it until you release. For this weapon, I want it to be automatic because it's a SMG. So I click fire auto. And then for the reload. All right. The last one doesn't need a tag because it's a passive ability, but I want to give it an auto reload. What this ability does, it's pre-built already in Lyra. It will check if the player the time between the last time the player shot, and if his magazine is not full, and if he has spare ammo. If that's the case, it will automatically reload for you. All right, let's save this one. Before we forget, let's set up our ability set here. All right, now let's create our ability that will be overwriting this two tag. The first one will be a weapon fire. Blueprint class, weapon fire. Go to the ability. Let's take the default one. So GA, weapon fire SMG. Let's open it up. And here, because it's the default one, we're going to have to set up quite a few things. The GE damage is basically a gameplay effect that will affect damage. I will leave the same as the pistol. The character fire montage will want the pistol fire. The delay between shot 0.1 is pretty good. And then the auto rate, let's put it to 2. The gameplay queue. Gameplay queue are not specific to Lyra. They come with the gameplay ability system, and it's basically a file that encompasses things like visual effect, like Niagara, but also audio, camera shake, force feedback, all of that into one single file that can then be called and executed through a tag. So for the impact, we'll leave the rifle impact, and for the firing, we'll do the pistol firing. So I go down, pistol fire. That will basically trigger that specific gameplay queue. Lastly, we need to add a cost. Our other weapon have already set up, but for this one, it doesn't have a cost. So we need to make sure that when you fire, it actually costs something. In our case, we want to change the magazine ammo. So we click add a cost, and then we'll want to change an item based on its tag. Open that up. We'll want to remove one. And then the tag will basically be our magazine ammo. So what that means is that every time that ability is triggered, it will remove one from the magazine ammo. Compile, save. Double check. I think we are good. Now we go into ability set and set up our new SMG weapon fire. Okay. Now we'll create a reload. So right click. Open class, reload. And let's take the pistol in this case, so we don't have to redo a lot of things. PA, reload weapon reload, sorry. SMG. Open it up. Animation is already set up because I took the one from the pistol, and we want to reload really quick. Compile, save. That's all you have to do. Ability set. Let's slide on new reload. All right, let's double check. Fire SMG, reload SMG, auto reload. Save. And this one is already set up. The next step would be to create a weapon instance, so actually an equipment definition instance. In this case, we'll want a ranged weapon. So let's do that. Right click, open class, and then weapon instance. And we'll want a ranged weapon. And the same, let's take the pistol so we don't have to file all the animation. So weapon instance, SMG. Let's open it up. Animation already set. And now let's play with the curve. In here, you can see the minimum spread and the maximum spread. I want this to change. I want the spread to be much bigger from the default. So let's do, for example, 4 and 18. You can see this value changing. The heat curve is per shot, how many the spread will grow per shot. This one is already pretty high with the pistol. And then how quick it cool down. The pistol has a really quick cooldown for its spread, but I don't want the SMG to have such a quick cooldown. So I put it to 3, and I'll add even more delay before it starts to cool down. The rest can stay the same, and you can play with this value and see what they do to the weapon. Compile, save. Now I'll go back to my equipment definition and tell him, hey, this item is actually an SMG. Compile, save. Let's double check that everything is set up correctly. We have our item definition that tells, it's missing the equipment. So if we equip, it would have not known what to equip. Now we tell him, equip the SMG. Give it 32 ammo magazine, and 64 spare, and use these two reticle. Compile, save. From there, we overwrite with our ability set. We show the weapon pistol, and we'll use this weapon instance, this item instance. So now let's minimize that, and we need to test it. The easiest way is to take one of these blueprints already made that are weapon spawner. This blueprint will basically use a data asset to tell which item to grant the player. So let's duplicate one of those. It has also a lot of parameters to change other things. So let's change, for example, the color. And now let's go create a weapon definition. That's the data asset it will use to know which item to give. So right click, miscellaneous, data asset. And then here, let's create a weapon pickup definition. Weapon pickup data SMG. Let's open it up. There is a few settings for the weapon spawner itself, like the cooldown, as well as the audio that can be used when you pick it up or respawn the weapon. And then some effect, which I'm happy with the ones I have here, so I'm not changing. And finally, a display mesh, so pistol. But the most important is the equipment that we want to give, the inventory item definition. That's what the spawner will give the player when he goes over it. In this case, we'll want to give an SMG. Save that. Make sure we actually give the SMG to that weapon spawner. And let's test it out. Press play. I'm on the blue side, so I'm going to go quickly to the red side. You can see I have already the pistol here, and I'll go over this, and I have a second weapon. It's still the icon of the pistol, but you can see I have 96 bullets. You can also see the reticle is quite different. This one is much tighter, this one is much larger and takes a while. And now if I press, it's an automatic weapon. You can also see that the reticle adapts based on the number of bullets and the magazine size. And there you go. You created a new weapon in Lyra. So now that we get a weapon, let's create quickly an ability. So go into Game, right-click, New Folder, and let's do a force field that damages only the enemy team. Right-click, Blueprint Class. And we create already a lot of classes for you to pick to have a good starting point. So you can take Lyra Gameplay Ability, GA, force field. From there, open it up, and you will have an Activate and an End ability. The only thing you will want to change is the replication policy, because I want this ability to replicate. And that's it. From there, we also expose a few functions for you to be able to grab easily reference from outside the ability. One thing is, for example, to get the owner, get Lyra character from actor info. This will return the character that owns that ability. From there, let's do a sphere overlap. So get actor location, sphere overlap for actor. Let's do a radius of 500. And let's check for pawn. Now, if we hit something, let's loop through them and see if they are from a different team. And to do that again, we expose quite a few things. So right click and you get team subsystem. This will come with a lot of function for you to do team related operation. So now we'll want to compare team, and we just have to fill the two actor. So the one that got hit with the one triggering the ability. If these are from different team, we'll want that character to apply damage to the other one. And to do that, we'll use a gameplay effect. So you could grab the gameplay ability system from that one, but we also expose that with a function. You can do get ability system, actor info. And from there, do gameplay effect to target. Oops, so we want different team. And our target will be the ability system from the pawn we hit. We want to check if it's valid. And if it is, it will receive damage. Now we need to create a GE for that. But before, let's also end our ability.
So to apply damage, we'll use a gameplay effect. And again, we prepare some for you. You could create one from the beginning or just use one that we already prepared for you. So if you write instant, we have a basic damage that is already all set up for you to use. GE, force field. Open it up. And I will recommend also to look at all the gameplay effect and ability we shipped with Lyra, as we use different way to do damage and use the gameplay effect and gameplay ability. In this case, we'll want it instant and we want a value of 35. You can also do some calculation and other stuff here. And that's it. Now I'll use the force field inside that ability, compile, save. Now let's overwrite our gameplay experience to actually use that ability. As we saw before, it's just about adding to the pawn some ability. In this case, let's take, for example, the emote, which is right now in input tag ability emote, and for the gameplay shooter is binded to B, and replace the ability with a force field. And we can play and test. So I'll go towards the other player. And if I press B, it's taking 35 damage. And as it's replicated, you can see it on both. And that's it. You now have an ability inside your game.
Thanks, Simon. So with the caveat that future plans may change, some of the areas that we're looking at focusing on for future releases of Lyra include demonstrating more online features, preparing it for console certification, and improved mobile touch controls and scalability. These changes will ensure that just as Lyra was a great way to start your game, it'll be in a good position for you to ship your game as well, making it easy to do online multiplayer cross platforms. So what are you waiting for? You can download Lyra right now on the Learn tab and get jamming. We're excited to see what you make, and give us feedback on what else you'd like us to improve for future releases.